Okay, so let's look at an example of how to calculate the molarity of a solution. And we might as well start with the example you have on your data sheet, which is on page 7, question number 1, where in exercise A, you made a solution that had 1 gram of sodium chloride in 120 mils of water. So let's do some calculations with this solution. So you need to calculate the concentration of this in grams per liter and osmoles per liter, as well as figuring out what the percent solution is. So we know that concentration is amount over volume. So we can express this as 1 gram per 120 mils. So that's a perfectly acceptable way to express concentration, except we want it in some other terms. So the easiest thing to do is to first convert it to grams per 100 mils. So we can say that 1 gram in 120 mils is equal to X grams in 100 mils. And then just cross multiply and solve for X. So this is pretty straightforward. So we get 120 times X equals 100 times 1, and X is going to equal 100 divided by 120, which is going to be 0.83 grams. So in terms of the concentration per 100 mils, we now have our solution is 0.83 grams per 100 mils, which by definition is a percent solution. So we have a 0.83% solution. So we've answered part C of that question. And if we want to convert this to grams per liter, we can do a similar calculation as we did here. We can say 0.83 grams per 100 mils equals X grams over 1,000 mils, because a liter is 1,000 mils. And when we cross multiply and solve for X, we end up with X equals 8.3 grams. So our new concentration, or it's the same concentration but just expressing it in different units, is therefore concentration is 8.3 grams per liter. So that answers part A of the question. Part B is what is the osmolarity of this solution. So we need to first calculate the molarity of the solution, and molarity means moles per liter. Moles per liter. So we now have our solution expressed in grams per liter, so we're almost there. All we have to do is a simple unit conversion to convert grams to moles. So what do we need to be able to do that? Well, we need the molecular weight of sodium chloride, and that is roughly, I'm just going to write it up here, molecular weight of sodium chloride is 58.5 grams per mole, roughly. Let me put NaCl right there. So usually students don't have any problem knowing you have to multiply or divide by molecular weight, and if you're like me and can't remember anything, then you need a little trick to help you remember. So if you multiply 8.3 grams by 58.5 grams per mole, your units end up being grams squared over moles, which is not right. We want it to be moles, so obviously we have to divide. So if we take 8.3 grams per liter divided by 58.55 grams per mole, when we divide, these units flip over and it turns into moles over grams, so our grams cancel out and we end up with 0.14 moles per liter, or we could just put a big M there, means the same thing. Well, to calculate that or to convert that to osmoles per liter, then we just have to multiply that by the number of particles that sodium chloride dissociates into when you put it in water, which is 2. So times 2, and that's osmoles per mole is the unit for that. And then way in the bottom corner here, we end up with 0.28 osmolar as our answer for that. So we just using some simple ratios have converted 1 gram per 120 mils to grams per 100 mils, which is the same thing as a percent solution, and then converted that to grams per liter. And you might notice a pattern here, and if you do your pre-lab assignment, you'll see to convert a percent solution to grams per liter, you end up multiplying by 10, and to go from grams per liter to a percent solution, you always divide by 10. So that's a simple way to do that. But if you forget, then just simply do this ratio and cross multiply trick, which always works. Then, because we now have our concentration expressed in grams per liter, it's then just a simple unit conversion to convert it to moles per liter. So the rule of thumb is convert everything into grams, moles, and liters before you start, and then you will have a simpler time doing your calculation. Now, you may have learned it in a different way where you have a whole series of boxes and you do everything all in one step. And if that works for you, great, do it that way. So whatever way you learned, if you can get it right that way, then I don't mind how you do it. But if you have trouble with these problems, then this is a good example of how to do it in a bunch of steps, but at least you'll understand what you're doing. So let's do another example of a slightly different version of a molarity problem that you might get. And that is, instead of solving for concentration, you might be asked to solve for amount. So that's one of the big tricks when you're looking at these problems, is decide if you're solving for concentration or if you're solving for amount. So you probably intuitively know that concentration is amount over volume, which is what we previously calculated was a unit of concentration. So here we're being asked for amount because the problem is asking how many grams of something do we need. So that's clearly a unit of amount. Moles is a unit of amount as well. And so to calculate that, we simply rearrange this and say amount, is concentration times volume. So you don't have to memorize too many things here if you do it my way, which is the minimal memorization way. So we know our concentration is 1.5 molar. Well, what does that mean? It means 1.5 moles per liter by definition. So let me just write that out there. So if you're given a concentration in another unit like millimolar or micromolar, then it's easiest to convert it into moles per liter first of all. Volume is 2 liters. So let me give that as 2 liters. And again, if you're given a volume in milliliters or microliters, it's easiest to take an extra step and convert it into liters. So now we just multiply. So our liters will cross out and we're going to end up with 3.0 moles, and that's a unit of amount. Well, we can't really weigh moles out very easily, but we can weigh grams, which is what we're being asked. So now all we have to do is convert the moles to grams. And again, we know we need molecular weight, but do you multiply or divide by molecular weight? Well, the molecular weight of glucose is 180 grams per mole. So I always try multiplying first because that's easier. If we multiply by 180 grams per mole, then we will be successful because our moles will cancel out and we will end up with grams. And it turns out that we need 540 grams of glucose to make 2 liters of a 1.5 molar solution. That is a whole lot of sugar. hopefully this is helpful. Again, if you are having trouble with this, please ask your lab instructor. If you can't contact yours, ask one of the other lab instructors. Contact information for everybody is in a document under course information on Blackboard.